Good morning. We are delighted to have this meeting in the new Congress of our Science and Space Subcommittee. NASA and the space programs have been in the news a lot in the past year. Some really impressive feats. And we're going to be talking about some of those, from the rover on Mars to the birthing of the SpaceX capsule at the International Space Station. I am delighted to have my colleague, Senator Cruz from Texas, as our ranking member. It seems like that Texas and Florida have some interest in the space program, and I'm looking forward to his leadership, and I would ask for his opening statement.
Well, thank you, Mr. Chairman. Let me echo those sentiments, say how much I'm looking forward to working with you on this subcommittee. Space flight and our capacity to maintain world-leading advantage in space flight is a critical priority for the nation. And certainly a critical priority both for the states of Texas and the state of Florida. And so I am eager for our collective journey to ensure that NASA and all of the related programs have sufficient resources, sufficient priority to do what needs to be done. And I appreciate all of the witnesses coming here today to address these important topics, and also to begin the process of what I hope this subcommittee will do over the coming years, which is continuing to make the case to the American people about the importance of these programs, about the benefits that they produce for the private sector, that they produce for men and women across this country, and at the same time looking for ways to improve those benefits, to expand the cooperation that we presently have between NASA and the private sector, and to look for ways to even further increase positive benefits that are realized in everyone's day-to-day life. And so I'm eager and looking forward to working together.
Thank you, Senator. In the interest of time, we're going to compress things today because there have been 3 roll call votes called at 11:15. So I'd like to see if we can get the bulk of the hearing in the time before the votes take place, so that we can be mindful of your time, because those votes will stretch out over some period of time. And we're going to get into some interesting stuff here today on space debris and also asteroids possibly hitting the Earth. So we want to have time to cover this. Let me suggest to each of you, keep your comments to 5 minutes so that we'll have a chance to get in depth in some of the questions. We have Dr. Jim Green, Director of the Planetary Science Division in NASA's Science Mission Directorate. We have former astronaut Dr. Ed Lu, 2 shuttle flights and a 6-day stay on the International Space Station. He's now the chairman and CEO of the B612 Foundation, and he's going to talk to us about his foundation's Sentinel, which is to track the near-Earth objects. And then Mr. Richard DalBello, Vice President of Government Affairs for Intelsat, who's going to speak about the economic role of satellites and the commercial and security implications from the space threats. And then Dr. Joan Johnson-Freese, Professor of National Security Affairs at the U.S. Naval War College. She's going to talk about the role of space in our daily lives and how the space threats can threaten our national security. We will put our formal statements for Senator Cruz and mine in the record. Your written testimony will be inserted in the record, and if you would just give us a quick summary so we can get into the questions, please.
And
Dr.
Mr. Chairman, I will confess, given the topic today, I was disappointed that Bruce Willis was not available to be a fifth witness on the panel.
We might get a trailer from Armageddon and show that. Dr. Green.
Mr. Chairman and members of the subcommittee, I am pleased to have the opportunity to update the committee on NASA's programs and our approach to addressing the risks, impacts, and solutions for space threats. One space threat is near-Earth objects, or NEOs. NEOs are asteroids and comets that enter the near-Earth space. They are primitive leftover building blocks of the solar system, making them also compelling objects for scientific study. Today, we do not have a complete inventory of all the possible impactors. NASA was tasked by Congress in 1998 to catalog 90% of all the large NEOs within 10 years. The large NEOs are those that are 1 kilometer or more in size. A large NEO would cause a global catastrophe if one struck the Earth. NASA now is cataloging up to an estimated 95% of all the NEOs over 1 kilometer in size. That said, none of these known large NEOs pose any threat of impact to the Earth within the next 100 years. It is a situation we are constantly monitoring. In 2005, Congress directed NASA to expand the survey to detect, track, and catalog NEOs equal to or greater than 140 meters in diameter. And Congress set a goal for this program to be achieved 90% completed by 2020. For this expanded survey, NASA's NEO program currently has 3 survey teams that operate 5 ground-based telescopes and are providing the nonprofit foundation, B612, with technical assistance and operational support through a Space Act agreement for their space-based survey telescope that we'll hear about today. NASA continues to make daily progress on this goal. Extreme space weather is another threat being studied by NASA. Space weather refers to the conditions on the sun, in the solar wind, and in the near-Earth environment. Our ability to understand the Sun-Earth system is of growing importance to our nation's economy and national security. The electric power industry is susceptible to geomagnetically induced currents, which can overload unprotected power grids and result in widespread power outages. In the spacecraft industry, intense geomagnetic storms have the capacity to disrupt normal operations such as satellite communication, and of course they pose risks to our astronauts in space. In addition, space weather can cause irregularities in the signals from our very important global positioning system. The National Oceanic and Atmospheric Administration, or NOAA, is the official source for space weather predictions for the nation. Several of NASA's research satellites have become an essential part of our nation's space weather prediction system, providing very important data for determining the space weather conditions. One such mission is the Advanced Composition Explorer, which sits in the solar wind ahead of the Earth, providing early warning of incoming solar storms. Finally, orbital debris is the last space threat I will address today. The Joint Space Operations Center, managed by the U.S. Strategic Command, is tracking more than 23,000 objects in orbit around the Earth, of which about 95% represent some form of debris. In addition, millions of smaller debris objects that can potentially damage spacecraft are orbiting the Earth. NASA continues to lead the world in studies to characterize the near-Earth space debris environment, to assess its potential hazards to the current and future space operations, and to identify and implement means to mitigate its growth. In conclusion, NASA is making great progress in understanding and developing measures for mitigation of these space threats. Again, thank you for the opportunity to testify today, and I look forward to responding to any questions you may have.
And you're going to put up, along with NOAA and the Air Force, Discover in late 2014 for giving us early warning on sun explosions, are you not?
Yes, sir, that is correct. Indeed, Discover is a mission that's moving forward. It's a NOAA mission, a space weather mission. Their first space weather endeavor at what we call L1, and it is indeed on track.
Okay. Dr. Liu.
Thank you, Mr. Chairman. I wanted to talk about asteroids and what we're doing about them. The B612 Foundation is a Silicon Valley-based nonprofit that's building the Sentinel Space Telescope. And that telescope is going to find and track asteroids. As we were reminded a couple of weeks ago, the Earth is sometimes hit by asteroids. The city of Chelyabinsk in Russia had an asteroid explode. That asteroid was only about 18 meters across. That would fit inside this room, roughly. It had an explosive energy about 25 times the bomb used in Hiroshima, or about 470 kilotons of TNT. The people of Chelyabinsk were very lucky. That asteroid exploded more than 60 miles from the city, and yet it still injured 1,000 people. The last major impact before that was in 1908 in Tunguska. That asteroid was about 500 times the explosive energy of Hiroshima. It destroyed an area about the size of metropolitan D.C., and it was only about a factor 2 larger. It would not quite fit in this room, but it's not much larger. So I'd like to start a video just to show you what the solar system really looks like. This is an anatomically accurate depiction of all the known asteroids in our solar system. So this is actually off of the JPL database. This is every single known asteroid. So the ones in the outside part of that is the asteroid belt. Those are the ones that won't hit the Earth. Those are the ones between Mars and Jupiter. The ones on the inside are the so-called near-Earth objects, and those are the ones that could hit Earth, and those are the ones that Dr. Green talked about. And those are the ones we're concerned with. There's about 10,000 known near-Earth asteroids, which have been discovered through NASA's Space Card program. However, we know that this is only a tiny fraction of those larger than the one that struck Tunguska out there. We know that there are about 1 million of them out there. We know this by counting craters and by knowing what small fraction of the sky we've actually been able to survey thus far from the ground. So it turns out that there's, of these 10,000 that I'm showing here, the light green line, by the way, is the orbit of the Earth. You can see how many of them fly past the Earth. There's actually about a factor of 100 more. For every one we know about, there's 100 more we don't know about, and we simply don't know when the next one's going to hit the Earth because we don't know where they are. The real situation looks more like this. This is what it looks like with 1 million near-Earth asteroids. And so you can see that the Earth really is flying around the solar system in a cosmic shooting gallery in some sense. And that's why these things hit the Earth. So let me tell you a little bit about the odds of an asteroid hitting the Earth. You may be surprised by these odds. The odds of a 100 megaton impact this century, and 100 megatons for scale is about 5 times all the bombs used in World War II, including the atomic weapons. The chance of that in your lifetime or this century is about 1% on a random spot somewhere on Earth. Now, the odds of a much smaller 5 megaton impact like we had in Tunguska, an asteroid that would not quite fit in this room, it's about 30%. A 40-meter asteroid is a 30% chance. So if I told you that there was a 30% chance of a random 5 megaton nuclear explosion somewhere on the surface of the Earth this century, what would we do to prevent that? And how is this situation any different? Yes, most of the Earth is unpopulated, and we could get lucky. But wouldn't it be a shame if the area of the next impact was an area that wasn't unpopulated? And there are less and less areas that are unpopulated. But there's good news. It turns out that we actually have the technology to deflect asteroids if we have a decade or more of notice. And NASA's been working on this. The National Academies has written a report on this. We understand how to deflect asteroids if we have advanced warning, because you can't deflect anything, you can't explore anything, you can't learn anything about something that you haven't yet found. That's the key. So in the next video, I'll show you what the B612 Foundation is doing. We're building a space telescope. It's called Sentinel. That's what it looks like. It's about the size of a FedEx moving van, and it is going to orbit the sun, and it is going to track near-Earth asteroids. According to the National Academy's findings, the best way to find asteroids is in the infrared, where asteroids are brightest, and from a vantage point where it can always look away from the sun. So in an orbit around the sun, something like Venus. So I'll show you here where this thing is going to orbit the sun, and that's where it can see the white disk that you see is what it can see. The light green line is the orbit of the Earth. So as Sentinel moves around the sun faster than the Earth does, it will scan Earth's orbit. So it's going to find about 100 times more asteroids than all other telescopes combined. So it will be far, far away more effective than all other telescopes combined. In the first of the, we have discovered, as Jim has said, about 10,000 near-Earth asteroids thus far with all of our telescopes over the last 30 years. Sentinel will discover that, roughly that number every 2 weeks. So it will be an impressive instrument. We've assembled one of the world's finest spacecraft teams to work on this, and we've chosen Ball Aerospace in Boulder, Colorado as our prime contractor. Sentinel is based on the design of the Kepler Space Telescope and the Spitzer Space Telescope, both of which were built by Ball. We launched in July of 2018. A couple things make this project unique. First, the B612 Sentinel project is being funded philanthropically. We are a nonprofit, and we will openly share the data with the world. Second, we are managing this project in what I believe to be an innovative fashion, using commercial procurement practices. I proudly served at NASA for 12 years as an astronaut, and I also had the privilege of working at Google. And I think that we are using the best of both worlds in managing Sentinel. We're combining the technical rigor of NASA, which is the best in the world, with the innovative, rapid, and cost-effective practices that I learned at Google. And the secret to success, as I learned at both of these organizations, is hiring the very best people, and I think we've done that. So I do want to talk a little bit about NASA. They have a very significant role in this. We are, in a true sense, a public-private partnership. We have a Space Act agreement in which NASA will be allowing us to use the Deep Space Network of telescopes to transmit our data, and also NASA experts are part of our review teams. So they are a very important part of our project. Sentinel will be important on a number of levels. So not only will it enable us to know if an asteroid is going to hit the Earth in time for us to actually deflect one, but it'll find asteroids that merely come close to the Earth. And this happens all the time. And these asteroids that come close to the Earth will be attractive targets for exploration, both human and robotic, in the coming years. So should an asteroid be found on an impact trajectory with Earth, and I'm reminding you that there is a 30% chance that there is a 5 megaton or larger impactor that's going to hit us this century. So should we find one, I believe that humanity will come together to prevent this. We will use our space technology to nudge this asteroid and prevent it from hitting the Earth. And I think that will be a watershed moment in human history. And so thank you very much.
And we want to get into how you're going to nudge it away. And we'll get into that. Mr. DalBello.
Thank you, Mr. Chairman, Senator Cruz. It's a pleasure to be here today to talk about the issues of space risks and how they relate to the commercial sector, the commercial operators who are earning their living day to day in space. We've been in this business for about 50 years. We're currently flying about 70 satellites. So we're pretty familiar with the space environment and the risks it entails. As a global fleet operator serving both commercial and government customers, reliability and continuity of service are our highest priorities. Whether it's UAV operations over Afghanistan or the final game of the NCAA tournament or financial statements that have to be transferred securely around the world, we know that our customers expect flawless performance. To deliver this level of performance, we have to daily deal with a range of threats. Probably the highest priority for us today, radio frequency interference. Many times it's accidental, sometimes intentional. Space debris and other challenges of space flight, cyber attacks, solar weather, space systems reliability, the fact that we today don't have an affordable technical solution for refueling and repairing satellites on orbit, and last but not least, an international launch industry that's far from robust. Now, our economy depends on the ability to create and instantly distribute vast amounts of data around the planet. Space-based platforms have become a vital link in the national and global economies, and they're essential to the prediction of weather, navigation in all kinds of transportation, the operation of power grids, the completion of local and global financial transactions, and communication to mobile platforms, whether they be on land, sea, or air. Commercial satellite industry also plays a critical role in supporting government operations. Commercial satellites supply the majority of communications in Afghanistan and Iraq. Today, our satellites are still flying almost all of the DoD's unmanned aerial vehicles, and we're providing the vast majority of the Navy's communications at sea. To address the challenges that I mentioned earlier, the leading space operators have gotten together on a number of complex cooperative projects. Probably the most significant of these is the Space Data Association, or SDA. The formation of SDA is a major step toward creating a voluntary space traffic control, if you will. It's an interactive repository of satellite orbit and maneuver information, and soon will contain the satellite configuration data. That will allow us to also use the same database to do radio frequency interference resolution. The Space Data Center allows satellite operators to augment government-supplied data with precise orbit data, maneuver plans, and to retrieve information from other member operators when necessary. Determining the orbit of objects in GEO is a complicated task. The U.S.'s current space surveillance network is subject to a number of constraints. Some of those constraints are weather, scheduling, geographic diversity, and overall capacity. Recent efforts within SDA to share owner-operator data provide clear proof of the value of collaboration. NASA and NOAA have both joined SDA and are providing information into this common database. In creating SDA, the private sector has taken the first step towards a new paradigm of managing risk in space, but to be most effective, far more cooperation is needed. In other areas of interest to this committee and being discussed today, such as space weather or highly uncommon events such as the asteroid flyby, there are no clearly established links between the government and the commercial sector. In space weather, although we are aware of the good work that NOAA is doing at the Space Weather Prediction Center, there's no established alert protocol between government and industry. Nor is it clear what levels of solar activity would mandate change to routine operations. So it's one thing that the information exists, but the lack of a communication ability to translate that is a significant deficit. For highly uncommon events such as an asteroid flyby, there's simply no established communication mechanism. I believe our flight operations team learned of DA-14 when they received a courtesy call from a colleague at the Aerospace Corporation. Last year, the commercial satellite industry participated in DoD's Schriever War Games. Now, these games are held every other year, and they're designed to exercise DoD thinking about the deployment of its terrestrial and space assets in response to a conflict situation. Last year, those games concluded, as they have several times in the past, that DoD relies on commercial satellite companies, their reliance is considerable, and that a crisis is the wrong time to try to establish clear lines of communication with your major partners and suppliers. I suspect the same conclusion can be safely applied to the topics that we're discussing today. While governments were first to send satellites to near-Earth space, commercial enterprise will be the primary user of the orbital arc in the 21st century. Governments and commercial space operators need to take a more collaborative approach to enhancing the safety of the space environment. The SDA is an important step on this path. With the support of the U.S. government, we can create an international framework that acknowledges the vital contribution of commercial industry while working to assure the preservation of the space environment. Thank you, sir.
And we'll want to know, Mr. DalBello, how you safe your satellites when there's a solar flare. Dr. Johnson-Freese.
Thank you. It's my pleasure and honor to speak to the committee today, just as it always is to speak to students and the public about space, which I do many times a year. I'm going to take a slightly different approach to assessing risks, impacts, and solutions for space threats by talking about the threat of the American public not understanding the importance of space. From my course on space and security at Harvard to speaking to the public about the immediate importance of space activity in their lives, the number one comment I subsequently receive is, why don't we know this stuff? Space, based on my interactions with the public, is not the final frontier. It's not the next frontier. In 1997, I co-authored a book calling it The Dormant Frontier, but it's not really that either. Quite the opposite, given the ambitious work being done on the International Space Station and other activities, though I contend that that work is largely unknown to the public. Space is, however, for many Americans not living around a NASA center, a benignly neglected frontier. The problem with space and public support that translates into prioritized spending of their tax dollars, is that the public views space much as most people view their cars. They just want them to work. They don't care about the mechanics of a combustion engine or how to build or repair the car. They just want to drive the car. Similarly with space, because of the resounding success of NASA and other organizations responsible for putting substantial space infrastructure into orbit, Americans, indeed people all over the world, use their ATM cards, use GPS in their cars and boats, and rely on the Weather Channel to tell them whether they should carry an umbrella, totally oblivious to the role that space assets play in providing that information. So in that regard, the immediate benefits of space activity are not forgotten to most of the public. Perhaps that knowledge was never known in the first place. Space is associated largely with exploration and so considered expendable during times of economic restraint, something that can be put off until later. But that premise is incorrect, even regarding exploration. Infrastructure isn't built or launched quickly, and once in orbit, it must be maintained and updated. Though because they use it, the public is familiar with some satellite systems, like GPS, but less familiar with others. For example, the probes that study radiation belts and satellites that watch for the solar storms to protect other satellites and terrestrial electrical grids are essential. Unfortunately, however, the public generally views these space activities as little more than interesting science projects, if they know about them at all. Yet without them, Americans' lives would fundamentally change. Let me explain with a few brief examples. GPS is, with the internet, one of only 2 global utilities. It facilitates, for example, having emergency response vehicles reach their destinations by the shortest routes, potentially saving lives. For transoceanic air travel to be safer and more efficient because planes can fly closer together. And if the new satellite-reliant air traffic control system is implemented, reduce jet fuel consumption by 1 million barrels annually, saving both money and the environment. And it saves the trucking industry an estimated $53 billion annually in fuel cost and better fleet management. In addition to the economic benefits of space, which are vital to the national interest, there are also direct security implications. Politically, the recent meteorite that hit the Russian Urals with the force of an atomic bomb was a stark wake-up call regarding threats from space, and certainly raised the importance of space surveillance and the communication of those threats. Given the complex political state of the world, it is clearly imperative that government officials have accurate scientific data to distinguish between meteorites and missile attacks. Since miscalculation is a historic cause of war, we must be aware of what's going on in our solar system. The military benefits of space are too lengthy to be cataloged in a short period of time, but suffice it to say that every letter in the acronym, which basically describes military operations, C4ISR, command, control, communication, computers, intelligence, surveillance, and reconnaissance, is reliant on space assets. Space surveillance allows the military to have eyes and ears into locations otherwise inaccessible and on a 24/7 basis. Geostrategically, America is hindered by our own success with Apollo. Especially in tough economic times, many Americans view space exploration with a been-there, done-that attitude. But for the rest of the world, space still represents the final frontier, the future, and consequently, global leadership. Space capabilities add to U.S. prestige and soft power, which has spillover into U.S. influence in multiple policy areas. 2 final questions tie many of these issues together and hopefully illustrate why a vigorous space program must be maintained. First, would China have conducted a high-altitude kinetic ASAT test in 2007 with the resultant debris threatening the sustainability of the space environment if it had been a partner on the International Space Station? Second, if called upon to deflect a meteorite threatening Earth, Are the technologies in place to do so, and are the mechanisms in place so it could be done without a geostrategic nightmare? In conclusion, America will stay ahead in space and thus capable of addressing these economic, political, military, and geostrategic risks and threats by staying active and staying ahead. Therefore, we must remind the American people and remember ourselves that space exploration and development is not expendable. It is in our strategic national interest.
Thank you to all of you, and I want to welcome, we have a number of emergency responders that are in the audience in a new kind of threat that we're talking about that they may have to respond to. And I suppose in response to one of your questions, Dr. Johnson-Freese, that as Senator Cruz had posed at the outset, maybe we ought to have Bruce Willis start doing another Armageddon movie to get everybody sensitized to the fact of how space could well play such a huge consequence in our lives if one of these asteroids starts coming toward us. So let me turn to Senator Cruz.
Well, thank you, Mr. Chairman, and there probably is no doubt that actually Hollywood has done more to focus attention on this issue than perhaps 1,000 congressional hearings could do. Although I would not wish 1,000 congressional hearings on anyone. You know, Dr. Green, Dr. Liu, I'd like to go back to your testimony and get a little bit more in terms of the magnitude of the potential threat that near-Earth objects could present. February 18th, we had the meteor strike in Russia. Did we have any real warning of that strike before it occurred?
Yeah, that particular day, it was February 15th, was really quite a special day because we actually had two events. The first one was a very close flyby of a much larger asteroid that we call DA-14. And that one we had been watching for over a year, and we calculated its orbit. We knew it was on a safe trajectory to pass by the Earth. Indeed, this much smaller meteorite of 17 meters in size that struck Russia was not observed prior to its entry into the atmosphere. It was on a very difficult trajectory for us to be able to see from ground-based telescopes and came basically in the sunward direction. So our telescopes operate from the ground in the evening, of course, on the night sky. One of the next major steps that has been now initiated by B612 is to provide a space-based asset that would plug that hole in a number of ways. And this is why our public-private partnership is extremely important for us to be able to continue, to be able to help B612 with the Sentinel mission to get up into space this decade, to then begin to observe many more of these objects that are on difficult orbits for us to see.
If that same meteor, instead of striking a relatively rural area, had struck Manhattan, what would likely the consequence of that have been?
This meteor exploded at altitude, 20 miles high or something like that, and again about 60 miles outside of the city. So had it struck over a populated area, say Washington or New York, it would have probably caused quite a few injuries, as it did over Chelyabinsk. But it wouldn't have taken out the city. It was too small to do that. But as you could see, even from a distance of 60 miles, which is a very long distance, it basically blew in windows and doors. Every window in that city was busted. And remembering that the shock wave that caused that drops off very rapidly the further away you are from it. Mm-hmm. Had that shock wave been much closer to a city, there would clearly have been a lot more injuries.
Now, my understanding is we've identified nearly 1,000 near-Earth objects.
10,000.
Well, nearly 1,000 that are a kilometer or more.
Yes.
Correct.
What would the consequences be of an impact from an object of that size?
Well, the large objects, the ones that are 1 kilometer and larger, are actually very bright. Those are the ones that we, starting 15 years ago, from the 1998 congressional action, really are the ones that we've been after. And indeed, we believe we've gotten well over 95% of them. What we do when we obtain that information is we calculate their orbits out to more than 100 years, and it's from that database that it's clear to us that those currently, the ones that we know of, will not pose a hazard. However, we're constantly monitoring them, and we constantly see them through our surveys. So from that perspective, that speculation is just that. It's speculation. So what we want to continue to do is, of course, get into space, continue our program on the ground, and methodically, over a number of years, complete the survey so that we can see what the real threats are rather than speculate.
Now, Dr. Liu, you mentioned that you think our current knowledge is roughly 1/100th of what is out there?
Yeah, of those larger than the one that missed us on February 15th, which is roughly the size of the one that struck in 1908. And so those are the ones that would be only large enough to take out a large city, for instance. Not something that would kill off civilization or send us into the dark ages, but maybe only destroy New York City. And of those asteroids, we know well less than 1% of those. So right now, the amount of warning time that we are likely to get from one of those is 0.
And let me ask a final question. What is our capacity if we discovered a sizable asteroid that was on a collision course? What is our capacity right now to do something to change that?
If you find it early, decades in advance, which is what the goal of NASA is to do and goal of the B612 Foundation is to do, we have many options. Then you only need to change its trajectory by a very, very tiny amount. Senator Nelson, you know from having flown in space that when you are many orbits ahead of time, very tiny changes in your speed make big differences in the timing of where you are many orbits later, and that's exactly what you do. It turns out, so in real terms, if you change an asteroid's speed by something like 1 millimeter per second, that's about the speed that an ant walks. And you do that 10 years or more, decades before it's going to hit the Earth, you can make it miss the Earth. So that means all you basically really need to do is either run into it with a small spacecraft, it's called a kinetic impactor. You can tow them gravitationally using a small spacecraft called a gravity tractor. For the very larger ones, the kilometer-sized ones, you can use a nuclear standoff explosion. These are all technologies that we believe we know how to do. The key is, if you don't know where they are, there is nothing you can do. If you have less than a few years' notice right now, we have no options.
There's another aspect of this that I want to mention, and that is these objects are very heterogeneous. There can be rubble piles. Their composition is quite different. Some have iron, some don't. Some are carbonaceous chondrites, stonies. And so consequently, it's important to know what you're up against. And in fact, this particular decade is a great decade for us to be able to do some of the research necessary that will contribute to potential mitigation concepts into the future. One mission is OSIRIS-REx. It's an asteroid sample return mission. It's going to an asteroid that's called RQ-36, which is a potentially hazardous asteroid in more than 150 or so years. But it gives us an opportunity to get up close to it, grab a sample. We'll orbit it for more than 500 days. We'll understand how the solar wind and the light from the sun potentially moves the object. And so this kind of study is essential for us to be able to really determine the potential mitigation strategies that we would use in future, potentially future missions that we may have to pull off.
So right now, until Dr. Liu gets his satellite up there in 5 years, we are just hoping that we can identify and then correctly calculate the trajectory that one of these asteroids would have. And assuming that we found one before you got your satellite up, let's go back to Senator Cruz's question. What would an asteroid that is 1 kilometer in diameter, what would it do if it hit the Earth?
That is likely to end human civilization.
So that was typical of maybe what hit at the time of the dinosaur age?
No, that asteroid was yet much larger, another factor of 10 larger. 10 in diameter larger, which makes it 1,000 times more massive. And that led to the extinction of essentially 90% of all species alive at the time. And those are quite rare. And we do not know of anything that large that's on an impact trajectory.
Does the fact, as we prepare to go to Mars and the stated goal of rendezvousing and landing and returning with a human crew from an asteroid, does that in any way help us perfect our ability to avoid this kind of catastrophe?
I think, obviously, there's great science you can do. I think likely the deflection mission that we have to mount someday, and we will have to someday, we know that someday, is likely to be done robotically, just because the distances are quite large from the Earth. But there is a connection between the two, and again, for the human missions to asteroids, you still need to find them. We do not currently have a set of good targets to run human missions to asteroids. So the same data set, which allows us to know if something's going to hit Earth, gives us targets for exploration.
Yeah, in fact, visiting an asteroid by astronauts, for instance, is another one of those steps in terms of understanding much more about their characteristics. But the ability to do that is an enabling one. It's one of those where you trek outside of low Earth orbit. You have a destination. You then go through a variety of processes and procedures that you would have to perfect on even longer voyages if you were to go to Mars. So there are different objectives with respect to that. But indeed, learning much more about our heterogeneous asteroid environment is incredibly important. And if I can just mention, build on what Ed has mentioned, 50 years ago, planetary scientists believed that all the craters that are on the moon were volcanic. We didn't know that they were of impact. And it really took many years for us to be able to realize that they were created by impacts. And then soon after that, we began to notice the impacts here on the Earth. And the impacts, of course, led us to the Chicxulub crater, which indeed now is believed to be one that has created the extinction of the dinosaurs. In the 4.5 billion years of this planet, there's been 5 extinction events, for which that one, we do believe, has been the one done by a near-Earth object. So over the last 50 years, we've learned an enormous about a brand new field, things that we needed to be aware of, and we've been putting in place a methodical program of observation by starting with the ground, by building on international partnerships, and also now with our public-private partnership with B612.
Well, until Dr. Liu gets his satellite up there, I hope you're paying your trajectory specialist well, Dr. Green.
Indeed we are.
Because they've got to be right on the ones that we know to make sure we know their trajectory. Tell us, Dr. Liu, and don't worry, I'm getting to the other two of you. Tell us about how we're going to nudge this thing and what is the potential cost? And are we getting the international community understanding that they've got to participate in this with us?
Well, I think again, I mentioned the way that you would likely do it in most cases is to simply run into it with a small spacecraft. Again, you just need to change its velocity by a very, very, very tiny amount. Following that, you'll probably want to hover a gravity tractor near it to verify that you have changed it the way you think you did, and to make any fine-scale corrections, something like a vernier burn on the space shuttle. You would do that with a gravity tractor. The cost of that, such a mission, I would believe it would probably be in the range of $1 billion or more to do a couple of missions like that, probably a couple of billion. But I think you would have to compare it against the potential losses of a multi-megaton impact. Also, in terms of the ability for the United States to show leadership, clearly such a thing would be led by the country that has the greatest technological capability, which is the United States and NASA in particular. I think the world will be involved in both the decision-making process and the actual implementation of such a thing. And I just again want to point out that there's a 30% chance that there's a 5 megaton or so impact that's going to happen in a random location on this planet this century. So this is not hypothetical.
By the way, why did this one in Russia explode at 20,000 feet?
Tremendous deceleration. You know, when you're moving that fast, that thing was moving about 12 miles per second. And at that speed, even hitting the air is like hitting concrete. And once it begins to come apart, it really rapidly comes apart, and it basically exploded.
And back to Senator Cruz's question, had that occurred over 20,000 feet over New York City, other than blowing out windows, what would have happened?
There would have been obviously many casualties. This one is a little bit harder to say. The one that over Tunguska, the one that was slightly larger, and the ones that I've been talking about, had that happened over a city, let's say New York City, we would have 7 million casualties, at least. Whatever the population of New York City is, they would be gone.
Really?
Yeah, the area of destruction of that impact was about 800 square miles. So there is nothing standing in an 800 square mile area of forest where that impact occurred.
And just to be clear, Ed is talking about the event that occurred in 1908 called the Tunguska effect.
Yeah, not Chelyabinsk.
And that was a much larger asteroid or meteorite.
What was the size of it?
We estimate it was about 50 meters.
Yeah.
50 meters.
Yeah. A little bit larger than this room, about twice the size of this room.
And
now,
the
50-meter impact, we believe occurs on the Earth every few hundred years.
And
so it's a rare event.
The one over Russia was about the size of this room.
Yes.
17 meters.
Did the one in 1903, did that hit the Earth, or did it explode in the air like this most recent one?
It exploded in the air.
I see. And the one that just entered the atmosphere at Russia, other than causing those windows, how many miles away from that little city in Siberia was it?
Over 60 miles away.
Wow. Did it flatten the forest?
Not really, no, because it exploded at a higher altitude than the one in 1908. So it was a huge shock wave, which doesn't blow down trees, but it certainly knocks in windows, as we saw.
Mm-hmm. And if that one had exploded over New York at 20,000 feet, you were making reference to the 1908 one. What would that have done to Manhattan?
If Chelyabinsk had exploded over New York City, obviously, we would have a lot more, because it would be a lot closer than 60 miles, obviously, then we would have a lot more than broken windows. That's for sure.
Mr. DalBello, you've got all these Intelsat satellites out there. What do you do to safe them when you have a solar explosion?
Well, that's an interesting question. The truth is that these satellites are on and they're operating. So a typical satellite today is probably about 70%, actually 70% full, so operating near its full capacity, and it's transmitting pretty much 24 hours a day. So there's no opportunity to turn it off without significant disruption to the service you're providing. That could be banking or media or the transmission of other important information or the flights of UAVs or communications with the military. So there's no real off switch on our satellites today. So they are on. And the question is, and this gets back to the issue I was discussing earlier, and the fascinating work that Dr. Green and Dr. Liu are doing, the question is always, how do you translate this information into practical warnings? When is it appropriate to translate information into practical warnings for industry? So in the solar example, a little bit more, I guess, a little bit more practical than some of the discussion on the asteroids, but the same question applies. how do we know what level of solar event will translate into a real impact on the satellites that we're flying? Now, we buy our satellites from the major manufacturers, Boeing, L'Oreal, Orbital, primarily here in the U.S. They are, of course, trying to build their satellites to operate in any environment. And the good news is that most satellites live well beyond their 15-year design life. So they're doing a great job. So the question is, at what point would an event happen that we would say, okay, it's dangerous to do something with the satellite now, we're not going to load code today, or we're not going to try to communicate with the satellite today, or we would maybe put the solar panels in a different orientation. These are issues that just aren't really very clear right now. So we would look to a collaborative effort with the manufacturers and the government to provide advice on this. Now, a similar thing happened in space debris. So a couple of decades ago, NASA got very interested in understanding the debris environment. That led to the situation where we have today, where we actually get warnings from the Defense Department. They're called conjunction summary messages. We actually get warnings in advance if DoD thinks that there might be a collision between two space objects. But it took us a long time to connect the basic information that we needed to gather to have the knowledge to the point where we felt comfortable warning people that they might want to take specific action. In this case, moving a satellite. So I think the same situation will apply with solar. As we get more sophisticated on the impacts, then we'll be able to translate those into specific actions. But today, that knowledge just doesn't exist.
Senator Cruz.
Going back to the discussion about potential meteor impacts, I would assume for an impact that the most likely place for an impact would be in water, given the percentage of the Earth that's covered by water. What is the relative severity of an impact on land versus an impact on water, and the consequences that would flow from one versus the other?
Depends on the size of the asteroid. To cause a tsunami, it actually has to be large enough to strike the surface. And as we saw, the smaller asteroids do not strike the surface. They explode in midair, which is worse. So the smaller asteroids, when they're over land, that can be more catastrophic. For the larger asteroids, when they strike the water, that could potentially be more catastrophic. For instance, and the way to think about it is essentially these larger ones create a crater in the water, which then fills in. So I don't know if you've ever been to Meteor Crater in Arizona. It was created by a small iron asteroid, and it's about 700 feet deep. It's about 1 kilometer across. And so had that hit the water, you would have a 700-foot deep crater in the water momentarily, which then fills in. So you know the size of the wave. It'd be about double that. If you think of a rock dropping into a pond, right, you get a wave that's about twice the height of that. So you get a 1,000-foot wave or so, something like that, coming off of something like that, which then drops off the further away you get from it. So that is one of the great worries, potentially especially with a couple 100-meter asteroids, the football stadium-sized asteroids. They're likely to hit in the ocean, and you're likely to have tsunamis. And as we saw in Fukushima, a tsunami can cause great damage and can affect that tsunami, which is not very large historically speaking, had a noticeable effect upon world GDP because of damage that it did in one prefecture north of Tokyo.
Do we have indication of near-Earth objects striking the water in the past and producing tsunamis?
It must have happened before. It's a little bit difficult to distinguish a tsunami that was caused by an earthquake from one that was caused by an asteroid. At least, in the past, in the historical record.
And using the example you used about the size of asteroid that struck Arizona, and what was the size that we expect that was?
The estimates of that are it's in the range of about 30 meters or so, so smaller than Tunguska, but larger than Chelyabinsk.
Okay, but that would likely not be large enough. I guess there it did strike. So
there
it did
because that one happened to be made of iron, so it was a lot tougher than the stony ones, which can explode at higher altitude. So even though that was smaller, it hit the ground. It's worth a visit, by the way.
I have not been, but I will have to add it to the list of places to take my daughters. And hopefully, what are the odds of the same spot getting struck twice?
Pretty low. By the way, there's an interesting impact site in Texas. It's about 100 miles or so to the east of El Paso. We used to see it in our T-38s flying back from El Paso all the time. John Young and I used to like to fly over it. John loves impact craters.
So using that example, you said that if a similar impact were to occur in water, we would see a 1,000-foot tsunami. What kind of distance would that be expected to travel where it would maintain?
It depends greatly upon where, the shape of the ocean bottom, the depth of the water, and so on. So I don't have a good answer for you. Also, the characteristics of that tsunami are going to be a little bit different than earthquake-caused ones, which we understand much better. Mm-hmm. And because those are sort of done by a line in a fault, whereas this is more of a point, more like dropping a pebble into a bathtub. And so the answer is basically it depends.
You also testified about your estimates of the probability of a 5 megaton incident or a 100 megaton incident, which, if I remember right, was 30% and 1% respectively?
Yeah, in the next century, in this century, yes.
Could you provide a little bit of the data that go into those probability estimates?
Yes, yeah. In fact, there's not a lot of scientific disagreement about that. This was documented well in the National Academy's report of 2010 called Defending Planet Earth, and that data comes from NASA, and there isn't a lot of dispute about that. And just for your information, where it comes from is from 3 different sources. You can count craters on the moon, you can look at your asteroid surveys with telescopes, and finally, there are DoD assets that look down upon the Earth for rocket launches and nuclear weapons tests. But mostly what they see is asteroid impacts that explode in the atmosphere. And that data much of that data has been declassified. And those 3 independent means of measuring the numbers of asteroids agree with each other. And that's why we have fairly high confidence in it.
Let me ask a final question, which is, in your professional judgment, and I would ask this to anyone at the panel who would wish to answer it, what else should we be doing to assess the threats that could seriously jeopardize human life and to be in a position to prevent those threats?
Well, from my standpoint, on this particular problem, what we need to do is a extensive survey of the objects in our own solar system. We know the locations and trajectories of the 1 million nearest stars because our telescopes can look away from the sun. We do not know the locations and trajectories of the 1 million nearest asteroids, and yet those things hit the Earth sometimes. And I think that's a big gaping hole, and our organization is working with NASA to fill that hole. And I think that's tremendously exciting, not just simply from the preventing death standpoint, which is obviously a wonderful thing, but from the exploration aspect of it and the inspirational aspect of it. Because, again, I think a demonstration that humanity can work together to go out there and do something incredible, changing the solar system to prevent our planet from being hit, is an incredible demonstration of science, technology, mathematics, astronomy, and all the things that make our country great.
Are there concrete steps that in your judgment would be prudent beyond launching the Sentinel satellite that you're working on that we should be taking in order to be aware of the potential risks?
Well, in the meantime, obviously NASA is running its own searches, and those need to be supported. They are also just began supporting a telescope system called Atlas, which is just at a couple $1 million. It's a fairly inexpensive system. What it's basically going to do is look for asteroids that just before they hit, to give you not to be able to prevent their impact, but potentially to be able to evacuate an area. So you might get a day or 2 or 3 notice before something hits. And that's the sole purpose there would be to simply get out of the way to the extent you can. And I think that's a great program. And it involves lots of small observatories around the world and students working on it, and I think that's a wonderful thing.
Yeah, from my perspective, let me build a little bit on what Ed said, and that is indeed we've been methodically had an observation program in place from the ground. We've also used other space assets. One is the WISE mission, which was an astrophysics infrared mission that had a particular orbit that made it appealing to be used to look for near-Earth objects. And that was quite successful. That really was the proof of concept for that next step. And that next step is indeed, as Ed mentioned, a survey, an infrared survey. And so we are working with Ed and taking that step. In addition, we have a really aggressive program to uncover much more the characteristics of these bodies. And we need to know those. As Ed mentioned, their composition are very different. Some are iron, and they pack more of a wallop. And so we need to go out and we need to understand other aspects of that would feed into a mitigation strategy. And that's one of the reasons why OSIRIS-REx, the next mission that we're going to do from a science research point of view, is also going to help us inform potential mitigation strategies. So we have in place a methodical program that we need to continue to work on and execute over this next decade.
And what is our ability in terms of a near-Earth object that's not that near to determine the composition of that particular object?
Well, it can be done in a variety of ways. We have the opportunities to hit it with radar. Radar is incredibly important. We have facilities in Puerto Rico that we use with National Science Foundation that we work with on that, in addition to our Goldstone radars. This enables us to get ideas about surface composition in a small way. We also, from the ground, make spectral observations. And indeed, from space, even several important points in the infrared will tell us a lot about its composition. So from a scientific point of view, we're doing a lot in that particular area, and that's helping us classify these and understanding their origin.
Dr. Johnson-Freese, you are constantly trying to get people to understand the relevance of our space program. There would be nothing like focusing the mind than survival with one of these things heading toward us. What about these and other threats to protect life on Earth and protecting our astronauts with all of the collisions that we find going on out there with space debris? How are we going to get the human space exploration to be conveyed to the American public? Just what is at stake here?
I think that goes back to Bruce Willis and Armageddon. And I'm all for Bruce Willis testifying, don't get me wrong. But after that movie came out, I was part of a project called Armageddon Fact and Fiction. And what that movie did was basically convince the American public that if anything bad happened, people would get in the shuttle and go fix it. It was myth. It was not reality. I think what we need to do is get far more of the information of the kind that Dr. Green and Dr. Liu have conveyed today to the American public. When I talk about it in class, when I talk about NEOs in class, the overwhelming response of my students is, I don't know anybody who ever died from a NEO. I know people who have died of cancer, traffic accidents, but nobody I know has died from a meteorite. And this gets into, again, the idea that we need to convey more of the fact and separate it from the fiction that the movie industry has really convinced much of the American public that we're all over it. We can take care of this. So I think there needs to be exploration and vision and inspiration is wonderful and has to be a component of our space program. But I think we need to get much better and much more aggressive at conveying the risks and the benefits and the self-interest in not just continuing but expanding the space program.
Well, the American people are certainly appreciative of the conveniences
Absolutely.
that they have every day, but do not know the connection, as Mr. DalBello has said, that all of these conveniences happen to be space-based, one way or another. Now, you take, that's why I ask about solar explosions, which is a nuclear explosion on the surface of the sun. It emits radiation. Unless satellites are safe or they're within the magnetic sphere surrounding the Earth that would repel this radiation, there's a possibility they're going to be knocked out. Let's take another scenario. What about a rogue country like Korea or Iran, if they get a nuclear weapon, which we certainly hope, and it's the United States' intention that they don't, but what if they put it on one of their rockets in North Korea, sent it up at altitude, and exploded a nuclear weapon? That would have some rather serious consequences, wouldn't it, Mr. DalBello?
It would be a very, very bad day for satellites, yes. The
Explain
radiation
that.
environment.
Explain that so our audience will understand that.
Actually, when we went back, when there was upper altitude testing previously, we did have evidence that the way it energizes the orbits also interferes with the electronics of the satellite, and if it's depending on where it is in altitude and which portion of the orbit you're in. I mean, obviously, satellites at geostationary orbit, which are 23,000 miles away, are a little bit safer. Satellites in lower Earth orbit would be saturated soon and would probably die because the electronics would be saturated by the energy released from the nuclear explosion. So a high-altitude explosion could have a very catastrophic effect on many of the satellites we rely on for weather, early warning, GPS, and a bunch of other very critical functions.
Dr. Liu, what would that do to our astronauts on the space station?
Clearly wouldn't be good. I've had the experience of being told to take shelter on board the International Space Station because of a large solar flare. That happened in 2003, and it's happened a few times since. But these levels of radiation could be much higher.
Senator Cruz. Staff. Mr. DalBello, your company has over 50 satellites in orbit.
Right, 50 that we own. We fly 70-some because we also fly satellites for other operators.
How do you build the risk to these satellites into your business model?
Well, we have always planning for a fleet of that size means that you're always doing several things. You're always, first of all, you're always building new satellites. You're always planning the launch of those satellites. And again, we haven't, this well beyond the topic of discussion today, but launch is still a problematic area for us. We wish the industry were much more robust and reliable. We welcome the entry of SpaceX and other new entrants into the marketplace, but it is still a challenging and expensive component. But so you're obviously building satellites, you're preparing to launch those satellites, and you are managing your fleet by moving satellites around in orbit in a way that in the past actually we really didn't do. Typically in the past you'd sort of put a satellite in one place and it sort of lived and died in that orbital location. Now it's much more dynamic. We're constantly grooming the fleets. We move satellites to meet demands. For example, when the war in Iraq started, we actually moved 2 entire satellites to the Middle East to accommodate the increase in traffic in the region. So it's a really dynamic equation, and so we do occasionally get anomalies. And when something happens, unfortunately, we lost a brand new satellite a few weeks ago when the launch vehicle failed, the sea launch vehicle failed, and that satellite was supposed to supply a lot of services. One was a military component in the UHF band, but it was also supplying a lot of television service to Latin America. And so we had to scramble to try to find replacement capacity. Sometimes we can find that in our own fleet, and sometimes we have to go to our colleagues and competitors to get that kind of capability. So the same thing applies more generally to any effect which perturbs the fleet. You know, there's not a whole lot of excess capacity in the sky, so it requires a creative and constant maintenance of the capacity and understanding where our requirements are.
The vote has started, so we'll wrap up in 5 minutes. Space debris is really a problem, and I was struck several years ago the deafening silence, lack of criticism of the Chinese when they launched their ASAT and blew up tens of thousands of pieces of space debris that are up there that just add to the problem. And the problem, even if we didn't launch another rocket on planet Earth, you'd have a real problem of space debris up there for some period of time. So, Dr. Green, what space debris removal technology is NASA considering?
That's a good question. I know there's a variety of studies that they are working on, and I'll have to get back to you with much more of the details of those studies.
Dr. Johnson-Freese, what are the legal and national security barriers to space debris removal?
One of the big barriers is that there are no salvage laws in space. So if the United States were to start an initiative today to clean up all the debris, we don't own it. We can't just go and get it. And you decide, are you going to get the little pieces? That would determine if you're going to use some of the techniques like foam to catch it, or do you go for the big ones? And from a legal perspective, if I went after a big piece of junk and grappled it and it broke apart, am I then legally liable for the damage caused to Rich DalBello's satellites? So there are many legal issues to be considered. And then the political and geostrategic, if, for example, you are using lasers. Well, I'm certain if the United States decided to start using lasers to deorbit large pieces of debris, that would make other countries of the world very nervous, just as it would legitimately make the United States very nervous if other countries were to do the same. So I think there's a host of not just technical problems, but legal and political problems. But debris and the NEO issue, I think, provide opportunities for international collaboration, require international collaboration, and for the U.S. to take a real leadership role.
Senator, can I make a brief comment about that? First of all, I completely agree with what Dr. Freese just said, but we are very interested there is a next generation of technologies that's not very far away. We know that DARPA is looking at this. We know that NASA is looking at this. We know that there are a couple of private sector opportunities that people have come to us with proposals. We're very interested in the ability to do more in space robotically. That's because it would be, for example, we had a satellite that went up a couple of years ago. One of the antennas didn't open, which meant that half of the revenue for the life of that satellite was lost. Had you been able to go up, grab that satellite, and just tweak that antenna a little bit, you probably could have saved the entire mission. So we think the technology is there today, and perhaps this is a good opportunity for another hearing. We know that DARPA has some forward-leaning programs that they're working on, and it is a technology that we in the private sector support fully and want to participate with the government on, because it's a valuable thing. That technology would also allow you, at a minimum, to remove very large pieces of debris from the most useful orbits.
Senator Cruz, anything?
Just want to thank all four of you for what I think has been a very interesting and productive hearing, and I thank the chairman as well.
Indeed, it has been most enlightening. We thank you for your expertise and your testimony. Have a great day. The meeting is adjourned.
Thank you very much.